Hello. This lesson is all about energy stores. It's the first lesson in an energy topic called the conservation and dissipation of energy. And in this lesson, I will be talking to you about some common energy stores, and so that you know what an energy store is, and talking about how energy moves between one store and another store. Okay, so let's start off by talking about energy. We use the word energy quite a lot, but what actually is energy? People talk about changing your energy provider, and you get energy coming into your house from the electricity companies and the gas companies. But what is energy? And I think it's fair to say that energy makes things happen. I think that's the best definition I can come up with. If you took the energy out of this room, it would be very quiet, it would be dark, it would be cold, and nothing would be moving. So basically nothing does anything without energy. And energy can be found stored in various situations here, and I'm going to talk about some of these energy stores which you need to know about. So the first energy store we talk about is a chemical energy store. I am full of chemical energy. I've eaten, and so I've eaten chemicals into my body. I've beans on toast, that kind of stuff, and so now I have the energy that was in that food is in my body, stored in the chemicals in my body, and I can release that energy to go about my daily business. There's energy stored in food. There's energy stored in some matches, in the chemicals inside a match. So when you buy some matches, you're buying a box of stored chemical energy, and you can release that energy into another type of energy by striking the match, and then we end up with there's some light energy coming off, which actually isn't a store, because that's just going somewhere and transferring one type of energy to another. But the big one that we use is the thermal energy here. So this is warm, and so the chemical energy stored in these matches has been turned into thermal energy and some light energy as well. So we have chemical energy in your bodies, in food, in fuels that we burn, also in this torch. This torch runs off a battery, and the battery is a store of chemical energy, and if I turn this on, the chemical energy in this torch is turned into light energy and a little bit of heat. Not so much, because it's all energy saving LED things these days. I have here very limited stuff because the school is shut. I've got my drill, and my drill has a store of chemical energy, a rechargeable battery which is full of energy, and then if I turn that on, that turns it into movement energy, or kinetic energy as we call it. It also makes a lot of noise, so that's some sound energy, and there's a little bit of light coming out of the top. So there are many different types of energy stores. We've done the chemical energy store. I mentioned briefly kinetic energy. Anything that's moving has got energy stored in it because it is moving. So if I move this potato and roll it across the table while that is moving, that has got kinetic energy. And when it stops, where's that kinetic energy gone? It's actually gone into some sound energy because it made a noise as it went across, and believe it or not, this potato is ever so slightly warmer, and this table is slightly warmer, and the air around it is slightly warmer, because the energy that the potato had, because it was moving, its kinetic energy, has been dissipated, which is spread out and turned into thermal energy with a little bit of sound energy as well. And once energy becomes too dissipated, too spread out, it's very difficult to catch it again and then use it for something else. So we have kinetic energy. Let's what else can we do with this potato? Let's give it some gravitational potential energy. So at the moment it's flat on the desk. If I raise it up a little bit, it has now got a little bit more energy stored into it. And if I raise it up again, it's got even more energy stored into it, and that is called gravitational potential energy, because it's stored. It's not going anywhere, it's just in there. And I can release the energy by letting the potato go. And as I release the energy, as it falls down, it's got less gravitational potential energy, and when it gets to the desk, it's back where it started from. But as it is falling, it gets faster and faster and faster and faster. So just before it hits the desk, it's going at its fastest, which means the gravitational energy has been turned into kinetic energy, or been transferred into kinetic energy. So halfway down, it's lost half the gravitational potential energy, and it's gained half of its maximum kinetic energy. And then by the time it hits the deck, it has got a maximum kinetic energy in the fraction of a second before it hits the deck, and no gravitational potential energy. We've got that. What else do we have? Elastic potential energy. I did have a spring, but I seem to have lost that. So I've got some rubber tubing. If I was to bend this, and then you can let go. So while that is being stretched, there's energy stored in this elastic. That could be in a spring, could be in a rubber band, could be in a plastic ruler that you're going to bend and let go of. But there's energy stored in the stretch of something, which is elastic potential energy. And then the other one, which I have mentioned already, is thermal energy. So if something is warm, if it has some more heat, then it has got thermal energy in there, and these are all stores. You go from one thing to another. I also briefly spoke about how energy goes from one form of energy to another form of energy, but you don't actually lose energy in total. Some of it gets spread out, but it hasn't actually disappeared. Now on the board behind me, I have got some energy stores. I've got chemical energy, which I spoke about, kinetic energy, which is the movement the energy something has because it's moving, gravitational potential energy, the energy is stored in something because it can fall, elastic potential energy sort of is stored in a stretch or a squish that's going to come out again, and thermal energy. Now I've crossed out the word electricity, because electricity is a way of carrying energy from one type to another. In this torch here, there's chemical energy in here, and when I turn it on, electrical energy runs through the wires to the bulb to make it come on. But the energy is not stored in those wires. It's just a way of transferring it from one place to another. So we don't say that the electricity is an energy store. So I think that's it for this one lesson. Basically, energy can be stored in lots of different ways, and it can be transferred from one type to another, but the total energy always remains the same, even though some of it may be so spread out or diffuse that you can't get it back again, and it's too spread out, and it's hard to make use of that energy. Okay, on the page in this book, which we're using, and it's on page 4 and 5 in my book, covers basically what I've been talking about, and there's also some questions there as well.